And now to switch from the Bossman teaching to the first person tutor angle. So let's do that. Oh, I'm a little too far. A little bit too far. So I have to apologize because I'm late. Supposed to be here at 12 and I'm an hour late. Yeah, a lot happened. A lot happened. I don't know. Is it washing and ironing clothes? I don't know. So what we have there, we have a base 2 number here and a base 2 number here, and we're trying to multiply them. Now mind you, obviously when you multiply it by 1 you just write it back, and when you multiply it by 0 you just write nothing, right? But then it gets kind of crazy because then, alright, it means that you'd have 1 1 1 0 0 1 1. Now let me apologize for putting it like that because it's kind of out of alignment. Alright, so that takes care of this one. Then I have to do that again. So 1 1 1 0 0 1 1. I put a 0 there. So that take care of this one. Oh. Oh. So the first one is a 0. Second one is 2 zeros. The next one would be 3 of them. Then we go 1 1 0 0 1 1 1, and then now then what again? Then 1 1 0 0 1 1 1 again. Yeah. This is why. Yeah, I can only imagine keeping track of all of this. I mean, I know how to do it, but we can't guarantee that for everybody. 1 plus the 3 zeros, that is 1. 1, 1 is 0, carry a 1. So I carry a 1 there. So 1 plus 1 is 0, carry a 1 again. 0, carry a 1 again. Now this is 1 plus 3, which is 4. This is where I get murky now. Right? So where I get murky. Because you have 1 carry a 1 if you have 3. Then what you do when you have 4? Is that 0, 0 carry a 1? You know? So that is the problem that I have with this method. You know, because you might run into, what do you do when you have 4? How do you write that? Because okay, in binary, right? So let's say that is 1. Let's say that is 2. Let's say this is 3. Then okay, if I add 1 to that, 0 carry a 1, 0 exactly. That is my problem. That is my problem. So if you have 0, 0 and then you carry a 1, what are we doing? Right? So that is my issue with doing the multiplication of binary numbers like this. Okay, it's too easy to get confused. Right? Not that it can't be done, but what you gonna do? Put a 2 zeros and carry a 1 over to where? You know, because you still have to add something over here. You know, a madness. It's just madness. It's just madness. And it can work, but I like to stay on the safe side so that I know what it is I'm supposed to get, right? So let me not take that risk with doing all of this, right? I mean, it's not very often anybody ever asks you to multiply base 2 numbers, but just in case, I like to do it this way, the way that I'm about to show you. The way that I'm about to show you. So, this is what I would do. Right? This is what I would do. So, let me put a bracket here and a bracket here. Now, 1, 2, 4, 8, 16, 32, 64. Right? So, okay. We have a 64. We have a 32. We have a 16. We do not have 8. We don't have 4. But we do have 2 and 1. Right? So that means the top number going to be, let me see now, this plus that 80, 80 plus 32 is 112. So 112 plus 3, this up here must be 115. Alright? Well, let's see if it add up now. This 1 to here, the 2 to here, 4, 8, 16, 32, 64. Yeah. So all of that line up. Alright, now, what about this one now? We have a 1 and a 2. We don't have a 0. So alright, let me write it again. So we have 1, we have 2. We don't have the 4. But we have an 8 and we have a 16. So 8 plus 2, 10 plus 6, 16. 16 plus 1. No, sorry. 10 plus 16 is 26 plus 1. It's 27. Right. So that's what I would do, right? So therefore, now I know that this is 115, that is 27. So, now, I guess the only thing left to do is just for multiply so let me say 115 plus 115, 230. So this would be, right? Then now 115 times 7. Let's see. Alright, so that's 805. Okay, so that means that what I will do is, let me just do this right here and put the so now that I have that, I need powers of 2 that I can compare that to, right? I will start with the number that's bigger than that. So let me start with 4,096. Then I move to 2048, 1024, 512, 256, 128, 64, 32, 16, 8, 4. There we go. So after some good start, right? Because it means that this is larger than that, so we're not going to entertain this at all, right? Now we're going to have to subtract 2048 from 3105, right? So what would that look like? What would that look like? So let me see what I can do to make this easier for myself now. What can I do? 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 Okay, alright. Let me be a dummy about it. So let's say I take 2,000 from up here and up here, right? So this will be 1105. And then 2,000 from that, leave me with 48. Then what else? What else can I do? This will be fun. So if I minus 5 from both of them, so 5 from that will give me that, and the 5 from this would leave me with 43. Alright, good. Now let us add 7 to this. Carry on 1, 5 plus this. Carry on 1. That's going to be, there we go. Yeah. So 1,057. So let me put that together now. Yeah, man, that work. So, let me just put the 1 right here. Right, we have 1 right there. Alright, this is good. it's good that we got the 1057. It's good that we got that. Because the next number we're going to use is going to be 1024. Let's make sure that. Yeah. So we subtracted 1024. Now we're going to go to. So let's see what we have here. Yeah, pardon me if my 4 look a bit yeah. Alright. So obviously that's a set of zeros right there. 5 minus 2. Oh, we have 33. Okay. Alright, so that means we have a 0 here, 0 here, 0 here, 0 here, but we're going to use 32. And then now, it's obvious now that if you take 32 from that, you're just left with a 1. So that means you have 0, 0, 0, 0. And that 1 at last. Yeah. So yeah. So this is what I like doing. I take my binary, turn it to a base 10. Take this binary, turn it to another base 10. Multiply this as normal for me to get this. Convert this into that. And it's easy to do this. Because just like that, we have a 2048 and 1024. We have a 8 and we have a 1. Oh, let me put the ticks beside them. Let me make sure so we have a tick beside. Yeah. Right? So there. Oh, wait. Why am I put that beside the 8? Sorry, it wasn't supposed to go there. It was supposed to go beside the 32 because, yeah. I don't know why I may have it beside the 8. 8 is next to a 0. Why did I do that? Yeah. So, we use a 2048, a 1024, a 32, and a 1. So if we add 33 plus this, all of that, when you add it, you end up with 3105. So what you're really trying to do is find out what is the the max number of the powers of 2 that can fit into the 3105. Right? Yeah, and that worked like a charm because there's nothing else to do. All you have to do now is just write this in order. So, okay. Imagine it in your head as 110,000 followed by, what would that be now? 100,001? Something like that. Alright. I'm going to write it over here just in case I forget it. Alright? So let me put it over here. So 1 1 with 4 zeros followed by 1 4 zeros and another 1. Right? So let me do that. I will leave out. So 1 1 followed by 1 4 zeros and a 1. Yeah. So that would be our answer for this. So this is our base 2, that's our, yeah. Now, naturally, you'll probably get easier numbers than this to work with, right? But yeah, I feel like this is a reliable way to get the job done. And I mean, you know, it's probably even more ridiculous if everything was ones, right? So imagine if it was this. Imagine if it got this ridiculous. So instead of it being, it having any amount of zeros, you have like all ones instead. Now the only clue I have as to what this is, let me see, 1, 2, 3, 4, 5, right? If I put a 1 out here and I replace all of these with zeros, what number is that again? So let's say I have 1 with 5 zeros. So if I add 1 to this number, I end up with this one up here. So if I know what this number is, I know what this one is, right? So let me see. This is 1, 2, 4, 8, 16. So the value of this number here is 32. Therefore, the value of this number is 31. So therefore, I can just put 31 right there. So let me get rid of that. And get rid of that. So now, similarly now, how much ones up here? 1, 2, 3, 4, 5, 6, 7. Alright, so you have 1, 2, 3, 4, 5, 6, 7. So imagine 1, 2, 3, 4, 5, 6, 7. So let me see now. 1, 2, 4, 8. Alright. So let me make sure. 1, 2, 4, 8, 16, 32, 64, 128. Therefore, this must be 127. Right? So if this is 128, that is 127. And you can prove that by doing this. If you add 1 to 127, you get 128. So if I add 1 to this, I'll end up with 0, carry 1, 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 0. Yeah. So yeah, that is proof that whatever this number is, if you replace all of them with zeros and put one more 1 to it, that would be the number that comes next. Right? So therefore, I can confidently say that this number up here is 127. Now another way you can do it is say, okay, well, 1, 2, 3, 4, 5, 6, 7. 2 to the 7 is 128, and minus 1 from it, and you get that. This is what? 1, 2, 3, 4, 5. 2 to the 5 is 32. 32 minus 1, give it that. So that's also another way you can look at that. Alright, so now now that we have that, let us see what we can do with this. So alright, this is not so bad though. So all we do is multiply 127 by 3. So 7 3s, we have 21. We have 8 here. Alright, so we have 381. So therefore, if we're multiplying this by 30, really? So the number is 3,810. Alright? All we have to do now is multiply that by 1 now. So we're multiplying 127 by 31. You have the 127 and you have this. So 3 here, 7 here, 9 here. Yeah. So we know we have 3,937. Alright. So we'll go to that now. Now, similarly, we know that it's smaller than 4,096. So we know that the first number that it can fit into is 2048. Then we just work we just working our way in this direction here. Alright, so obviously we're going to use 2048. So what happened when we minus when we minus 2048 from that, what happened now? Let me see now. If I take 2037 from both of them, it's like I have this, this, 37 from that, so I have to take it from the top and that too. So I take 2037 from that. I'm only left with, yeah, this is what I want. That is what I want. And so 9 carry a 1, 2 plus 8. Right. Right, so we have 1889. Alright, so the first, so we have 1 right here. Now we're going to take away 1024 from this. So let's write 1889. Alright, so what we have now, this is going to give us 865, okay. So we have 1 here and a 1 here. Let's make sure that let's see now. We take away 512. See what happens when we subtract 512 from this. That leaves us with 353. So again, we used that right there. We don't have a choice now. We have to use the 256 too. So let's subtract 256 from this. Alright, so if I take away 253 from both of them, I would have 100 at the top. Below I'd have 3. So 100 minus 3 would be 97. So this would leave me with not that anybody can even see that. But yeah, it is 97, right? So we used the first of these. Now we don't use 128 because 128 is bigger than 97. But I think now we're in a good place, because if you add 64 to 32, you get 96. So that means we can use these two and forget about this and just add the 1. So therefore we would have a 1 right here, 1 right here, 0, 4, everything else except the last one. Yeah, that was an adventure. All right, so let me see now. 41011. Okay, let me write that. 41011, right? And then 1, 2, 3, 4 of the zeros, and then a 1. So 1, 2, 3. Yeah. So to put a long story short, any of the numbers we're not using, we just put a 0. So we have 1 of this, 1 of this, 1 of this, 1 of this, none of the 128, 1 of this, 1 of this, none of these, and 1 of that. So we can literally draw a line through the numbers we're not using. So we don't use 16, we don't use this, we don't use this, we don't use that, we don't use that. So if we add up only the numbers that we never cross out, then all of this, when you add them, give you this number over here. So if you add 2048 to 1024, 512, 256, and then you add that to 97, you end up with that number up there. Now, let me check my calculator. Make sure that what I have here is actually the right thing, yeah? So I'm going to the calculator for verify what we do. Alright, so let us multiply 127 by 31. Alright, so that is in fact 3,937. Just like what we have over there, right? Now let us add 2048, 1024, 512, 256, 64, 32, and finally and just like that we get back our 3,937. Yeah, so that means, yeah, everything else is actually a zero. Yeah, so therefore everything we have here actually makes sense. And I mean, this is your 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Just like this, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Yeah. No, I don't even want to get into division because I've seen them try to do that, and that no, I don't know why you would ever need to divide a binary number by another binary number. I'm not trying to figure out that. Alright? But no, there is something else, but that has some computer science madness. Because when I was doing when I do my bachelor's at UTech now, they had this number system called hexadecimal, which when we hear that, my brain just shut off. Because I wonder what that means. But long story short, hexa means 6, decimal means 10, so 6 plus 10 means base 16. So therefore, for us, we were using base 2 numbers, octal, which is base 8 numbers, and then when we weren't using base 8 numbers, we use hexadecimal. So we skip out base 4 because we use base 2, we use base 8, and we use base 16. Yeah. So something like that. Is there anything else that, anything I do right now is something miscellaneous, right? It's a bit miscellaneous. So I was literally looking through one of the maths book name I use, right? I saw something that I never really entertained this kind of factorizing before, right? So I ran into something that looked like this. I ran into something that looked like that. And I'm not gonna lie, it never made no sense to me. Not initially, anyway. Not looking at it. That never made no sense. It just never made no sense. However, I said, hold on. There's something I know about this. This is what happens when you multiply xy by xy, right? So you can safely call it xy all squared. Because if you multiply xy by xy, you end up with x to the 2, y to the 2. Right? Now, what if I decided to put that in bracket as well? And then furthermore, what if I decided to replace that with a letter? So instead of it being xy squared, it becomes b squared minus b minus 30. Now, the good thing about this is that even if you want to call it the AC method, the coefficient of this is 1. 30 times 1 is still 30. So therefore, we're not focused on A and C, it's just C we are focused on. Right? So we're not have to worry about that. Not have to worry about this out of so. Just the 30. Now the 30 consists of 3 prime numbers, 2 times 3 times 5. Now if I want to combine them to get, let's say, something in front of this called either a positive or a minus 1, we need to combine. So I can either combine 2 and 5 to get 10 and 3, but 10 minus 3 will give me 7, whether it's a plus or minus 7, so we now use that. It could be 5 and 3 to give me 15 and 2, but that will be plus or minus 13. We're now going to use that. So we'd have to use 2 and 3, which will be 6 and 5. Therefore, you would be using a minus 6b and a plus 5b. Right? Because if I owe you $6, but I give you 5, I have 1 left to give you. Right? Just so that we, have a practical idea of what that is. So, when we're factorizing this now, we can say you can put a b here, then you would have a minus 6 with a plus 5. Now the good thing about all of this now is that now that you reach here, we only have 1 step left. So we replace xy with b. Now we'll go switch it back. So now we put xy here, xy there, and yeah, that's it. So yeah, sometimes you have to make sense of the nonsense, right? Because when I saw this, I never believed that I could have make something out of this to get back this, and it never made no sense. But now, if you were to multiply all of this here by what's on the right, you end up with that up there. So you end up with x squared y squared plus 5xy minus 6xy minus 6 times plus 5 is minus 30. Everything come out. Everything makes sense. Everything come out to make sense. So yeah. Okay. I'm looking at some change in the subject of the formula that I've never seen before. So, alright, we have, for both of them it says make D the subject of the following, or of the formula. Or in other words, you want to say express D in terms of whatever else, right? So, it says make alright, so Okay, so I'm going to get rid of this now, seeing that this finally makes sense. So let me get rid of that, let me get rid of that. Okay. So the one that they're asking us for is, alright, V is equal to 1 over 4 okay, so we have that now. There's another one I go do, but I'm just doing this one right now. Now, what I normally do, I color the letter that I want, right? That's what I normally do. So let me just color the letter that I want. So normally I color that. So fine, let me just put it on the other side. 1/4 pi alright, so we have that. Okay, this not that difficult. We want to get rid of the quarter. So let us just imagine that we multiply this by 1 and we just put 4 underneath all of this. Right? So just do that to save time. Now if you want to get rid of that 4, you multiply both sides by this 4. Right? So something is downstairs, you put something upstairs, right? So now we are left with trying to keep this in blue. Right. So 4 over 4 is 1. 1 times this give you that. V times 4 is 4V. Alright, so now we're going to divide. In other words, this is already upstairs, so we'll have to put something downstairs. Get rid of what is in black. So what we do to the left, we do to the right. So that leaves us with this. So the last thing we have to do now, so after we get rid of all of this, so now we have d squared. So the one thing we have left to do now is put a square root over this. Square root over this here, and a square root over that right there. And once you square root anything, it's like hurricane to roof, it tear off a roof, so therefore you are left alone. Hurricane tear off a roof, and I do that. So let's see. If I put that back up here, square it to get rid of that. Pi h times that, 4v times 1 over 4, yeah. Yeah, so all of that work out. Now I'll go to the other one now. Other one I saw was y is equal to the square root of 5 dx over 7. Alright, let's see. y okay, so the thing that look like it giving me the most problem right now is the square root. Right, that look like it'll give me the most problem. So and you know, I don't know why I never just write it a little bit closer over there so I can just flip it around. Alright, so let's just do that. So let's alright, so we want to, so when you want to get rid of a square, you square root. When you want to get rid of a square root, you're going to square. So you're going to square the left and the right. So square this and we square that. So that get rid of that, leaving us with now there's a way to make this happen really quick. So imagine this as 5x over 7 times d equal to y squared. So let us change it to that. 5x over 7. Now if you think about it like that, now you can flip this upside down. So when you flip it upside down, it's 7 over 5x. So you're going to multiply both sides by so in your next step you will end up with 7y squared all over 5x. That's on the right. 5x divided by 5x is 1. 7 divided by 7 is 1. 1 times d is just d. Now let me remove this. So let me remove this. Let me remove this, that, and bring it back to what it was. If I were to substitute that up here, what would I get? I'd end up with 7y squared over 5x times 5x. 5x is cancelled. 7y squared divided by 7 would be just y squared. So I'd end up with the square root of y squared, leaving me with just the y. Yeah. What I did see something else, you know, but I not even remember what number or how I numbered the page. I think I looked at this. Let me look on this one. Can't even remember what page number I had. Oh wow, yeah. Alright. So now I want to look at something that's a little bit on the crazy side. Just a little bit. Okay. So let me see if I can make sense of this. Alright, so this is 153. Nah, whoever wrote this was kind of, yeah, sorry, hold on, give me a second while I, you know, said they might go try and make me drop my phone. Hold on there. And yeah, okay, what was I saying now? See, they make me lose my page. They make me lose my page. Alright. What was I looking at? No. Come on. Okay. I found it. Family. I don't even know what to start first, right? Alright, let me do this first and see. Alright, so you have okay, alright. Okay, alright, fair enough. So you have that. Then you have what's the second part? 0.36? No, not 6. I don't know why I said that. 1 point. Y equal. Okay. Alright. Now there's only one good thing about this, right? Even though the whole of them look like decimals and whatnot, all of them only have one decimal place. Which means if you easily want to solve this problem, simultaneous equations, right? The first thing you want to do is treat the left and the right the same. And what you're going to do is, if I multiply 1.5 by 10, I'll end up with 15 because it did that. So if all of them have one decimal point, then I can multiply everything by 10. So if I multiply this by 10 and all of that by 10 and all of this by 10 and all of that by 10, I should end up with something looking like 15x minus 7y equal 1 and 3x plus 11y equal 25. Yeah. And then, well, for me, alright. The LCM of 3 and 15 is 15. The LCM of 7 and 11 is 77. So, I'm going to cancel x's and cancel y's. So I'm going to do that on the left and on the right. So if I multiply everything down here by 5, I can leave everything up here. Yeah. So if I multiply this by 5, this by 5, this by 5, what I would have is I'd have a 15x plus a 55y equal 125. Right? So just to put a long story short, I multiplied everything here by 5 and everything here by 1. So therefore this up here will stay the same. 15x minus 7y is equal to 1. And now we have to be careful with this. When the sign's 4, once these signs are the same, we're going to subtract. So if they're both positive, we subtract. If they're both negative, we still subtract. Right? So that's the important part of this. So we're going to, so 15x minus 15x, that will be 0. So that will cancel. Minus 7 minus 55, that's minus 62, right? So this will be minus 62y. Let's write it properly. Oh, and then 1 minus 125 is minus 124. Or we could have just make both of them positive. We could have subtract it in the other direction, same thing. If we said 55 minus 7, would end up with a positive 62. 125 minus 1 is positive 124. So we're going to get the same thing. So we're going to divide both sides by minus 62. (62 plus 62 is 124. So y is equal to positive 2. Yeah. So that take care of this side, right? This is when you make the x's cancel each other out. All right, so now let's go to the y's now. Now for the y, seeing that the LCM of 7 and 11 is 77, both numbers are prime, you have to multiply them together. So if I want this 7 to become, well, 7 by 11, 11 by 7. So 7 is multiplied by 11, and 11 is multiplied by 7. So 150 plus 15 is 165. So you have 165x. Then what else? Oh, minus 77y. (11) on the outside there. And then now 7 times 3, 21x. And then you have a plus what? 77y equal, alright, 25 times 7, 175. Yeah. So this will be Let me write my equal signs in blue. Oh, forgot to do that. No, the coefficients of x were the same, so we subtracted. The coefficients of y are different, so instead of subtracting, we're going to add, right? So we will have that going on. So so obviously subtract this from this, 15x minus 15x, right? You add this to that. Yeah. So this is strange. All right. This is 186x over here. But that's also okay. So we get to an answer easy now. We don't have to kill up ourselves. So we divide both of them by 186. So therefore, yeah. So our answer for x is 1. 15 times 1, 15. 7 times 2, 14. 15 minus 14 is 1. 2 times 11 is 22. 1 times 3. 3 plus 22 is 25. Yeah. Yeah. Well, that never as bad as I thought it would have been. Right? It could have. Yeah, it could have taken longer than that. So let's see what else they have there. Yeah, I mean when they're all the same, alright, it's only okay. Right. Yeah, alright, there are some that look kinda crazy. Yeah. Alright, so what I did was number 7. Number 15. Okay. Yeah, number 15 is it's built different. All right, let me write it. Let me write it. Let me write down number 15. So this is the one where you have a mixture now. This is where you're going to see 2 decimal points and 1 as well. So let's see how that work out. Alright. So it starts by saying 2.32x plus this and then 4.8x. Is it plus or minus? See, I have to be careful now. There's a minus 1.92. Yeah. So all of this So once I started doing this, it went into what I did before was a simultaneous equation as well as this. I know what I would do with this. I know what I would do. Let me just eliminate the decimals, right? So instead of multiplying by 10, I'm going to multiply by 100 for all of them, right? That means that I would have 232x plus 144y equal 1560. Now, I need to find out if I can divide all of them by the same number, right? I wonder if I can find the HCF of all of these numbers, because trust me, I don't really want to deal with this. Alright? Can I do this? Is the real question. Alright, 2 11s. Let me see what this is. 2 11s, 22, right? 23 minus 22 is 1 right there. 12 divided by 2, that is alright. Okay. Last time I checked, if I divide that by 2, I get 58. So I'll have 2 times 2 times 58. But 58 is 2 times 29. So chances are the prime factors of 232 will be this number. So I want to see if they all have I want to see if they all have numbers in common. So we have, I'm not even waste no time. 12 times 12 leave me with this. Alright, what about 1560? Why? That is a number. Alright. I know something about 156. If I add 12 to 144, I get 156. So 12 times 13. So that means I have 12 times 13 times 10. Okay, so that means I have a 2 up here, well, a 5 somewhere, a 13 somewhere. So 2 by 5 account for this 10. 13 is accounted for as well. So it's just a 12 I have left to put in. So I'll put 2 by 2 by 3. There we go. Yup. I had a feeling that there was a HCF. I had a feeling. So now they do have something in common. The HCF and how we know? Two by 2 by 2 in all 3 lines. So if I divided each number by 8, I would have, so fine, this was 232x. So now this is, that is 29x. So if I divide 144 by 8, I'm left with 18. So this would be 18y. And then what? 39 times 5. So 390 divided by 2. Yeah, 390 divided by 2. So $19 times 2, 38. So 195. Okay. Right. So therefore this would become $195. This would become 18y. Yeah. So this allowed us to divide all of that by 8 to give us these numbers here. Yeah, so move that. You know what? Before I do that, let me at least get a picture of it so that way I can remember the madness of this step. Yeah, it would be nice if my tablet did not do that to me. Alright. Okay. So let me get rid of that now. So at least we started out this line, we turned this to this, and it became that finally. Right? So we have that. Now let's see about, let's do the same thing here. 480x minus 192y equal yeah. So similarly, we're going to try to figure out if we have a HCF of these numbers here. So alright, we have 480. Let me put the x there too. 192, let's put the y there too. Now, something interesting about this. If I add 144 to itself, I would get, just so that I'm making it all make sense, I get 288. Therefore, yeah. So therefore, this part here is 144, and I add it to itself, meaning I multiply it by 2. Alright, 192. 192. Sounds like 64 multiplied by 3. Yeah, 64 multiplied by 3. So that's going to be 1, 2, 3, 4, 5, 6. Alright. Alright, we have something. We have something. Obviously I put a y beside it, just, you know. And then what's the last thing now? Okay. So may I try to make sense of this now. 480, which is 12 times 4 times 10. Alright. 12 times 4 times 10. So let's see. This part is my 4. Okay. This part is my 12. So we have the 48 part of it. But I have to multiply the 48 by 10. So I have to put 2 here and a 5 right there. Alright. Yep. So now we can start looking for what them have in common. Okay. This is something. 1, 2, 3, 4, 5. 2's and a 3. Okay, 5 2's and a 3. Yeah, it's 5 2's and a 3 for all of them. So 5 2's and a 3 here. And I have to be careful how I select this one. 5 2's and a 3 there. And one more time. 5 2's and a 3 here. Make sure so I have the right thing there. Yeah. So 2 to the 5 is 32. 32 times 3 is 96. So, right, okay. So if you divide all of these by, so the HCF for this is going to be 96, right? Yeah. So we just want to be careful about how we do this. So if we were to cross out that out of everything, we'd be left with 5x, 2y, and 3. So it would be 5x plus 2y, and that is equal to 3. So therefore, yeah. So let me take a picture of that too. No, it's kind of dark. Whatever. We can always find another way to screenshot that more reliably. I can always do that. Alright. Yeah, so I desperately wanted to do that, so that because obviously dividing it by how much numbers over and over, it wouldn't make no sense, right? So if I divide 480 by 96, I end up with 5. If I divide 192 by 96, I end up with 2. If if I divide 288 by 96, I end up with 3. Hence, the 5x plus 2y equal 3. Yeah. So, yeah, so we deal with, so we did that, right? So, fine. Let me just get rid of up here. So, yeah, the little primary school math save we. You know, believe it or not. You know, little HCF save we. Oh, hold on. I'll get rid of this madness right here. So, yeah. So what we're going to be focusing on is 29x plus 18y equal 195, 5x plus 2y equal 3. Now, the LCM of 29 and 5, both of them are prime, so we have to multiply 29 by 5 and 5 by 29. Right, so there's that. The LCM of 2 and 18 is going to be 18. So it means that we're going to have to multiply this line by 9, leave up here alone for the right side, but up here we multiply by 5, down here we multiply by 29, and that's what we do on the left hand side. Alright, so just give me a second while I try to get something. Yeah, don't know if that will actually work. I'll try. Maybe I should do it like this for the other one then, but whatever. Beggars can't be choosers, yeah? Yeah, alright. So, alright, let me try and hurry up with that one now. Okay, so we have our left and right. Right, we have our x's and we have our y's. Right, so over here is what we do to x, over here is what we do to y. Right, let me see. Even though we could do it another way, 290 divided by 2, same thing. So we have 145. Alright. So that means we'll have 145 x right here. So we multiply this by 5, multiply that by 5. Oh, that's 90. Okay. And then so 18, 1, 7, so 975. Okay. Alright, so this will be alright. Then now we multiply down here by the 29. So this will obviously it's going to be the same 145. 29 times 2, that's 58. Oh, guess what I'm gonna do wrong? Yo. Oh Lord. Yeah, that would have been a problem. Yeah, imagine if yeah, that would have been a nightmare. That would have been a nightmare. The answer would have definitely wrong. Alright, let me try and bring this across. Alright, 29 times 5 is this, 29 times that, 29 times 3, that's 87 if I remember correctly. And of course, coefficients of x have the same sign, both of them positive. If they were both negative, same thing, right? So we can minus both lines, right? We'll minus that. So 145x minus 145x. The whole point of it is on the x's you get rid of the x, and on the y's you get rid of the y's, right? So this is why this minus was necessary, because when you have a minus, for lack of a better term, it becomes a plus, right? Just, yeah, I'll explain after another time, right? Basically, it's like, you ever hear them say two bull can't in the same pen? Basically that. You can't have two negative people around each other. No, that's two negative. So therefore, something have to change. Somebody have to change, right? So that's basically the essence of that. 9 plus 5, 14. So this will be 90 plus 58. This will be a positive 148. Why? And then, what we are doing with this now? Oh, so we have a, alright, 5 plus 7, 12. 1 plus 7, 8. So 8 plus 8, 16. So we have that. 1 plus 9. Okay. No, I don't even know if that's divisible by that. I don't even know. I don't know. I'm hoping it is. I'm really hoping it's perfectly divisible. I mean, I can do that separately, you know. I can do that separately, but when I have a space. 1062. Alright, let me double check that too. 975 plus 87. Right. As I suspected. Cool. Divide that by. Nope. I thought it was perfect. It's not. It is not perfect at all. Anyway, alright, that part on the left side done. Now for the right side now. So up here not going to change. So the 29x plus the 18y. So that not going to change. But we're going to multiply everything down here by 9. 9 5 is 45. We have that. What else? 9 2 is 18, right? So we have the 18. And then 27. Alright. So they had the same sign over here. I will subtract, but because the signs are different, we are going to add them now. So 9 plus 5, 14. So we're going to have 74x. And then that is equal to, alright, 1 plus the 19, 20. So that's 222. Yeah. And as I suspect, I doubt that this is perfectly divisible. So let's see. Wait, this is? So, look here. So, if I divide both sides by 74, the x over here is equal to 3. But then what's going on over here? 29 times 2 is 58. I know say that right. 29 times 5 is 145. I know say that right. 29 times 3 is 87. Yeah? Anyway, whatever. So let me see what would happen now. If I put 3 up here, 15. 3 minus 15. What? Nah. So it's supposed to be? So what did I miss? What did I miss? What did I miss? Let me do something. So we have this. If I divide 1560 by 8, I get 195. Alright, so that's correct. Let's go again. I divide 144 by 8. I get 18. I divide 232 by 8. I get 29. So everybody like so what am I do? What I do? No, wrong. Let me try this again. 1062 divide this by 148. See? Unless, but I doubt that though. I doubt it. Alright, let me see what would happen if I use. No. Subtract 58 from 90, that would have been. No, that still would work. Anyhow, I'm going to divide this by that anyway. Going to do that anyway. So, whatever this is as a fraction or as a decimal, we will just put that down. Alright, whatever that is. But that's weird to me though. Because when I put x in here, I get 15. If I minus 15 from both sides, I get minus 2y equal minus 12, which y would that give me 6? So yeah, I'm kind of thrown off by that. Why would that happen there? Alright, let me go again. 195 minus 87. You have 108. What? And the thing is, it's not like I don't recall doing anything wrong. So that's the part that kind of beating me right now. Because if x is 3, then y is supposed to be 6. But when I put this there, I'm not getting that. So what is happening? $29 times 5, 145. 18 times 5, 90. This times 5, that. Alright? This times 29, 145. This times 29, 58. This times 29, 87. Yeah, I don't know. I'm right now puzzled. How is it perfect on one side but the other side don't make no sense to me? Like, what's going on? What's going on? Because, alright, here one. Let me humor myself and write down the number 6. Alright? Let me humor myself. Let me humor myself a little bit. 15 minus 12 gives you 3. Yeah? It gave you that. Last time I checked. Now, 18 times 6, that would give you 108. And 29 times 3 would give you 87. When you add them together, you get 195. But these numbers, nah, give me that. So, let me see something. Yeah, no. So, what is going on? Something down with the sense. Alright. Oh, that's what. Oh my God. Now I see what I did. Oh my God. I see it. I see it. I see it now. I see it now. Let me tell you what happened. Listen to me. Come here, I wonder why am I not get the 6 over here, so. Yo. Alright, so look at what happened. This is why it's important to not like skip steps, right? This is 145x minus 145x. That's done correctly. So you get 0 here, so, right? 90 minus 58 is 90 plus 58, resulting in this. Where did I go wrong? 975 is not being added to 87. You subtract 87 from that. That is where that. Come here, I wonder why I'm not get the right thing. This is what I was messing up. I was not supposed to get 1062. I'm not supposed to add them. Right? It's almost like I saw this and I add them and then I come over here and add that too. So okay. So you see, that's the importance of not skipping the steps. Right? This is 145x minus 145x. This is 90y minus 58y, 90y plus 58y. So this is good, this is good. It's this part, that part. Alright. So my trick is minus 75 from here and here. Right? So that means I would have 100 minus 12. 100 minus 12 would be 88. Therefore, this should be, yes, that should be my answer right there. Well, what I should have had as the numerator, right? Yeah. So, no, why am I saying 100? 900 minus 12. If I subtract 12 from 900, I end up with that. Now, when I divide this by 148, yeah. So, that's the importance of remembering what exactly you're doing in each line. So this is 145x minus 145x. This is 90 minus 58. I was so caught up in trying to get this correct that I ended up doing this part wrong. Yeah? So, okay. My conscience would have bothered me if I never get this sorted out. So I apologize for being stuck here. Right? I should never have, I shouldn't add 975 to 87. It should be this subtracted from that. Yeah. Alright, so yeah. Yeah. If anything else, or rather, I should probably just do anything else that come to mind some other time. Right? That's what that is. Oh, they have the, what you call it, the worded version of it as well. They also have that. Yeah, they have the worded version of that. What else? Well, what I could do is write the examples of what I'll do next time. That's probably what I should do, right? So maybe. So today what, Tuesday? Right. So let me change this to say what I should be doing tomorrow, right? So for tomorrow, let me write the madness that we're going to be looking at. Listen. What even is this? Okay, so we have like 2 over x minus 3 over y is equal to 1, and 8 over x minus 9 over y. Hold on, let me not say that. Wait, is that 1? Hold on. No, I can't. What is that number? Fam, is that 1 over 2? Let me just look on this. Oh, it is 1, thank God. Yeah, it's 1. 1 and 1 over 2. Okay. Here. Right, that's one. That's one of them. Yeah, no, they're starting to just. They're. All right. Okay, so now we have f minus 2g plus 3. What is this? Is equal to 2f minus 3g plus 2. And all of that is equal to 1. I need to even use like let me use the blue marker to separate the equal signs. That way we know what is happening. So this, right, so this is number 1. That's crazy. Oh. I don't think I did this one yet. But this one not go too difficult. Based on what we did in number 7. Let's say we had 2.3x plus 1.8y equal 5.1, 2.4y, and this is 0.3, 0.9. And then what is that? Hey, but no say them not them there's no way them are gonna put this on the paper ever again. But them know this are gonna mash up everybody. Like what? We'll look on this. Alright, that's 1/2 and 1 and 1/2. Alright. So you have x plus y over 2 equal 1/2 x over 2 minus y over 6 equal 1 and yeah. Might as well handle that as somewhat unfinished business, yeah? So that I must do tomorrow. And there are others, but yeah, there's not enough space for that. It's not enough space for that. Not enough space. So that is where I stop for today. Alright? I stop there for today. So till tomorrow, yeah, I'll start at 12. Yeah, hopefully I don't have anything. No, based on what's going on, I'm not gonna make that mistake like today. Today I was late. So anyway, yeah. So tomorrow at 12. Yeah, tomorrow at 12.